Find the exact value of. Surely we cannot find the exact value of the blank screen. Find the exact value of that arithmetic expression that is given in fractional form. First of all, we will convert the mixed numbers to improper fractions. The first one was done on a previous slide. Well, since it's not in this audiovisual, we will say that it was done in a previous audiovisual. The next one will be done in this audiovisual. And what will we do? The denominator multiplied by the whole number, and we will add that to the numerator. The resulting denominator will be the denominator of the fraction. Now, what we have here will be simplified, and of course we will place it in its rightful place. So it's going to be 4 times 1, which is 4, plus 1, which is 5, and the fraction will be 5 quarters or 5 over 4. Goes right there. What do we do next? Simplify by a common factor of 3. And what we are talking about, the product that we have right here. Simplify by a common factor of 3. 3 into 3, 1, and 3 into 21, 7. There we have it. 3 into 3, 1, and 3 into 21, that's 7. And no doubt we will keep a track of our progress on the right hand side. So we have 7 ones 7, and then of course 5 ones 5. That will give us 7 over 5, or 7/5, and it will take its rightful place right here. 7 times 1 is 7, and 5 ones 5. We've said that already, and we have not only said it, but we are showing it right here. 7/5, and no doubt we will continue by subtracting 5 over 4, and we will do that according to the way that we generally manipulate fractions by addition or subtraction when they do not have a common prime factor in their denominators. And the simple way is to say that we multiply the two denominators, and that will be the denominator of the resulting fraction. So we multiply those two first. 5 fours. Then the leading diagonal will go next, and that will be 7 fours will go next. Finally, the subordinate diagonal will go next. The subordinate diagonal, and that will be 5 times 5, that goes next. Well, I am yet to determine what this animation will do next. Maybe it will simplify the expression that we have there, which would surely be a very good idea. So there we go. 5 fours 20. The denominator goes first. Then I think that we will have the result of the leading diagonal. 7 fours 28 will go next. And we will follow up with the product of the subordinate diagonals. There we go. And that will give us the final answer. For sure, the numerator of the result will be the difference that we have represented right here. And that is 28 minus 25, which is simply 3. I'm just forgetting that the denominator, we always manipulate the denominator first. So we have the denominator returning just as it is, and then the numerator will be the difference of those two numbers that we have in the numerator. So 28 minus 25, and that will be simply 3. And of course, we have a final statement that we will make. The statement must be executed from left to right. The statement must be executed from left to right. That is how a mathematical, algebraic, arithmetic expression is manipulated. However, we have rules of precedence. Multiplication takes precedence over subtraction. The multiplication process was carried out first, and we are speaking in reference to the early manipulation in which we simplified right here, meaning that we are multiplying these two before we do the subtraction process. And that is why we had this done first, because we need to execute from left to right. As a matter of fact, there's no rule broken, there's no exception, because if we do that, it is still from left to right, because the multiplication process is to our left, and as a matter of fact, to the left of the subtraction sign. Therefore, we would just be following the correct order, or the regular order. But if it were second, then we would do the multiplication first still, because multiplication takes precedence over addition and subtraction.
For access to hundreds of free videos, please subscribe to our YouTube channel, Richard James Mathematics Resources. For unlimited access to thousands of exclusive full-length videos, please subscribe to our Vimeo channel, Richard James Mathematics Resources.